So horizontal asymptotes. Did you learn the rules where if the degrees are the same, it's the leading coefficients? I'm looking at certain people. Okay. And if the bottom has a higher degree, other way. That's a different one. If the bottom is a higher degree, it looks like, I'll erase this in a sec. So the bottom is, the top is a cube or a squared, the bottom is a cubed, it's 0. The horizontal asymptote is 0. Okay? If it's higher on top, you get a slant or oblique asymptote. I didn't teach my class that, but we'll go over it here. It's pretty easy to do. Okay? All right, so those are the rules. You need to know the rules. However, in limits, the very first unit of calculus, you learn what the actual definition of a horizontal asymptote is. Okay? So those rules come from the actual definition. So what's the horizontal? It's 1, right? Because the degrees are the same. If you look at the leading coefficient, it's 1 over 1. So the horizontal is just 1. Yeah. Okay. X-intercepts. People in my class should know this. How do you find the x-intercepts? Whatever makes the numerator 0, right? After you've done all your factoring and canceling. So what makes the numerator 0? Negative 4. That's your x-intercept. Okay, we can sketch this. And it's just, every teacher does it. Every teacher does it differently. Okay. Vertical asymptote. What did we say the vertical asymptote was? 1? X equals 1. Horizontal asymptote. 1. What else? X-intercept is negative 4. Negative 4 is here. That's our x-intercept, so we know we go to that point. Y-intercept was negative 4 as well. So there. What else do we have? POD, negative 1 and negative 3 halves. Negative 1, negative 3 halves, say there. So there's a hole right there. I'm just marking points right now. Is that okay? Yeah? Okay. So this part of the graph is straightforward to draw because you know it has to go through that point, has to go through that point. Can you touch a vertical asymptote? No. Can you touch a horizontal? Occasionally you can. You will learn why in a sec. We're not going to deal with any graphs that cross a horizontal early. You can cross a horizontal when it's close, and I put close in quotes because that's dependent on the definition. Close to the origin, when x is small, you're allowed to cross it, but as you go to infinity, it doesn't cross. That's for calculus. We're not in calculus yet. We're in review mode of calculus. So we have to go through all those points. So the graph just looks like this. Boom. And that's a really bad drawing, but okay. That's that half of the graph. How do you figure out where it is on the other side of the vertical? You pick a value that is on, like an x value that is on this side of the vertical asymptote. It doesn't matter what value. So pick a nice, you can pick a big one or a small one, doesn't matter. I'm just gonna pick 2, okay? Right, is that okay? Because it's bigger than x is equal to 1. So if you pick 2, and I go, okay, not x, y is equal to, and you plug 2 into your, just use the leftover function, the simplified version. And I go 2 plus 4 over 2 minus 1. What's 2 plus 4? What's 2 minus 1? All right. All you care about is that when x is 2, the y value is 6. All that really matters is you're above the horizontal. Y is 6 is up there. Just has to be above the horizontal. It has to go through that point. You can't touch that. You can't touch that. So the graph looks like that. And that's your graph. Now, 99% of the time, they usually alternate. Not all the time. Okay. We do a whole unit on curve sketching, where you go into the real detail of the curvature of the graph and stuff. I think we should do other one. All right, just for practice. We'll make it fun. Oh, we should do domain and range. That's what we should do. Tie it all together. Look at that. I'm not feeling the love, people. Domain, range. All right, you can use the equation or you can use the graph. What is x not allowed to be? Or -1, right? Because you've got a pole. So this is where looking at the graph actually helps. Okay? So follow the graph. We come from negative infinity, way out here. You follow the line. We're all happy. What happens there? Fall into the abyss, right? So the domain is negative infinity up till -1. Can you be -1 or infinity? Negative infinity. No, so they're rounded brackets. Then what happens? Climb out of the hole. And you go shooting down to negative infinity. So, what's the interval here? -1 and 1. Does it include either one? No. Boom, boom. What do you put between them? All right. Are we done? Because then on the other side of 1, then we go shooting off to infinity again. So then it's 1 to infinity. 1 to infinity. So you can see with a union in between. This is actually the power of the interval notation, is you can see exactly where your like mini domains, if you want to call them that, are, right? Because if you're going to do inequality stuff, you can't just say x can't be plus or minus 1. But this has value when you're doing limits and when you're doing graphical analysis. You can look, because the curvature can change and over a certain interval. Anyway, that's down the road. All right. What's the range? What's the lowest y value? Negative infinity. So we come up. What's the y value there? -3/2, right? Where was it? Right here. Okay. So it's negative infinity to -3/2. Boom, boom. Can't be either one. Then we go from there all the way to 1, right? -3/2 to 1. And then we go from 1 to infinity. Those are really bad infinity signs. Looks like a fish. Yeah, whatever. We'll go with it. Okay. I think we should do another one. It's going to make one up, and you're going to do all of that. Okay? And that'll bring us up to the end of today. Time flies when you're having fun, doesn't it, people? Yeah. All right. I was aggressive? All right. Let me pause this video so that I can think of a good one. We need a good